Page 2 of section 1.6, and now we're going to talk about equations of functions, and we'll go back to thinking of infinity as the output. In section 1.4, we had talked about when we find a limit of a function, if we use direct substitution, we plug the number that x is tending towards in, and we get 0 divided by 0, we can manipulate the function to evaluate the limit. For example, we would factor, multiply by a conjugate, etc. But if direct substitution gives us a number divided by 0, then the limit does not exist. So over here, for example, I've got the limit as x tends to a, and if I plugged an a into both of these functions, if I got something other than 0 on top, but I do get 0 on the bottom, then the limit does not exist, but we can provide some information about it, how it behaves really close to the value of a. So it's either going to be getting closer to positive infinity or negative infinity. Keep in mind, we don't normally write the plus sign, but that was just for clarity in the definition. So for my first example, I'm given the limit over here as x tends to 4. I plug the 4 into the function, and yes, I got a number divided by 0. So what we can do is look at numbers super close to 4, as in numbers to the left of 4 and numbers to the right of 4. Where, for example, 3.9999 is just to the left of 4, and so I'm going to plug that in for both of my x's, and we could turn around and do the math to get an answer, but without worrying about that, I have 3 something minus 5, so I'm going to end up with a negative value. 3 something that's less than 4 minus 4 is also going to be a negative value. A negative divided by a negative is positive. So on the left side of 4, this function is headed up. We don't know where it's coming from, but it's going up like this. Now when we go to the right side of 4, just barely bigger than 4, plugging it in where both of the x values were, again, we could do the math and we can see what's happening, but I just think about 4 is smaller than 5, and because it's 5 is subtracting from it, we'll get a negative. But this is slightly bigger than 4, and we're taking 4 away, so we're still going to have a positive, and a negative divided by a positive is negative. So somewhere over here at -4, which actually, sorry about that, we're coming from the right, so I really should be doing this way, right? It's headed down towards negative infinity. Now, let's take another example. I'm asked to find the limit of 1 over x as x tends to 0. We know that we can't have 0 in the denominator, but I have a number up top. So I can look to the left of 0, like negative 0.0001, or I can look to the right of 0, positive 0.0001. And obviously 1 stays negative no matter what we do, but if I plug a negative in, I'm dividing by a negative to give me a negative infinity limit, or I'm plugging a positive in where a positive divided by a positive is positive to give me a positive infinity output. And then the last piece to think about is back to infinity as an input. Think about a pizza that you're sharing with one other person, 2 other people, 3, 4, 5, 100 people, 1,000 people. It just could keep going, right? So we have this equation right now, our picture over here, that says we've got this one piece of pizza and we're dividing it by, well, we don't know how many people yet. So we're back to that 1 over x equation. Well, as x keeps increasing, we can take the limit as x tends to infinity, and we're going to get 0 out. So keep in mind, we can't actually plug infinity in, or numbers that are close to infinity in the sense that it's too big to compute on a computer, a calculator, whatever the case is. Sure, we could plug, 1 million in and see what happens. But basically, we know that our slices keep getting smaller, and so that's kind of what you're thinking of. If you had 1 over a million, then you're going to end up with 0.1, 2, 3, 4, 5, 1, which is basically 0.